Hi everyone, welcome back to our channel. So today we are going to discuss about the importance of the characteristic equation of a delay flip-flop. Okay, so hope those are available online. You can see here and we'll start move. Okay, hope audio is also audible. So coming to the concept, so characteristic equation of a delay flip-flop. So what is this characteristic equation of a delay flip-flop? Actually, the meaning of first we should know what is meant by D flip-flop and what is meant by D. Okay, so here D means this is nothing but a delay flip-flop. Okay, so actually what is meant by flip-flop means this is an one bit memory storage device. So if you want to store either 1 or 0, then we can use an flip-flop. So a flip-flop is an 1 bit memory storage device. And to make this storage to work or to flip-flop to work, then you are going to require clock pulses. So these are nothing but the clock pulses. So this is called as level 1. This is called level 0. Therefore, a flip-flop will work based upon the clock pulse that are given to it. Okay. So now let us try to see. Already in the previous class, we have been discussed about the characteristic equation of an SR flip-flop. The same we are going to do here, but we are going to get it delayed by logic of 1. Okay, for one cycle, it is getting delayed. Okay, now let us try to see it how it is getting delayed with respect to its timing diagram, and let us try to visualize it how it gets delayed by one clock cycle. Okay, so here it is delayed, but how much it is delayed is it is delayed by one clock period. Therefore, these types of flip-flops or one-bit memory storage device are called the type of flip-flop. Now let us go inside to understand what is meant by the characteristic equation. Okay, so now we will be having generally an SR flip-flop. So this is a basically an SR flip-flop, and here we're going to have the output states as Q as well as Q bar, where Q and Q bar are called as a bistable states. Okay, so Q is one and Q bar is another one, where these are called a bistable bits or bistable. I mean, two stable states are available at the output of D flip-flop. But how to connect this D flip-flop is, so you have to take one input is D and another input you're going to perform an inverter operation and you're going to connect to R flip-flop. So this is how the circuit diagram of an D flip-flop is there. Okay, so now if you want to draw it with respect to what there internally in this SR flip-flop using an NAND gate. Let us try to discuss. Okay, so already we discussed this NAND gate output. Now let's try to redraw it. Okay, so I'm going to have an S here. I'm going to have an R here, and here I'm going to have one NAND gate, and here I'm going to have one more NAND gate. These are connected like this, and you are going to have two NAND gates that are connected in cross coupled. Okay, so this is one input and this is another input. These two are connected in cross coupled. Cross coupled means the input of this one is connected to the output and the output of this one is connected to the input. Okay, like this these two are connected in cross coupled, and you're going to get the output state is q and another state is q bar. So these two are in self complementary nature, and it is going to have two stable states. First stable state is q and another stable state is q bar. For example, q is equal to 1 and the stable state will be 0. So this is how you have to understand, and these gates are basically NAND gates, and this is the basically the design of an SR flip flop. Okay, so this is called SR flip flop means set reset flip flop. Okay, so set means one, reset means make it 0. This is nothing but one bit memory storage device, and you're going to have the output as q and another output as q dash, and we are going to take the first input is D, and D is connected to S, and the inverter is connected to R. So this is how the diagram of an SR flip-flop with D as an input, where D is called as an delay input, and with a delay of one clock period is going to have. Okay, so now let us try to draw the characteristic equation of our D flip-flop. So coming to here, I already told this NAND gates, this flip flop, you have to give the clock pulses. Okay. So basically, this clock pulse is an edge triggered clock pulse. Okay. So this is called positive edge triggered. Okay. For example, if you take the clock pulse, this is called positive edge triggered clock pulse. This is called negative edge trigger clock pulse. And these clock pulses are necessary to make the flip flop to work. Now coming to the positive and negative clock pulses, when you give here, therefore it is going to perform the action like this. Now let us try to develop the required truth table. So the truth table of an, so now let us try to see this truth table of an D flip flop. So what is this truth table of a D flip flop means? Already we are going to have the first one is clock pulse. So clock pulse is the first one, and next one we are going to have the decimal way of representing this clock pulse. Just write down one more column as decimal, and we are going to have the first input is D, and another input is qn. So these are nothing but two states, and next one is nothing but qn plus 1. So where qn we are going to call it as a present state. So what is the present state? So this is nothing but the present state of our flip flop. Qn plus 1 is nothing but the next state of the flip flop. Now let us try to see here. Okay. So now how many inputs are there? Two inputs are there. If two inputs, how many possible outputs you can get is 2 to the power 2 is equal to 4 possible outputs you are going to get. So this is a clock pulse 1, this is a clock pulse 2, this is a clock pulse 3, and clock pulse 4. And in this is like an positive edge trigger clock pulse, and the decimal values are 0, 1, 2, 3. And how to write down in the decimal value is this is 2 and 1, this is nothing but BCD values. So 0 0 means you can write down 0 0, and here write down 0 1, and here you can write down 1 0, and 3 we can write down it as 1 1. So what is the output of this value is so later I will try to derive the how we are going to get qn plus 1 is equal to d. For the time being, to get the output, let us estimate the next state is qn plus 1 is equal to d. So what is the qn value is d value. What is the d value? 0 0 1 1. So whatever the value of d is there, the same will be duplicated here. So this is how we had drawn the SR flip flop, and from SR flip flop we get the delay flip flop, and we had drawn this SR flip flop and delay flip flop with the help of NAND gates, and we had developed the truth table. Now let us try to go forward to develop the characteristic equation of this flip flop. So coming to the characteristic equation. Okay, so this is very much important to understand. So the characteristic equation you are going to do it now. So here in this characteristic equation we are going to get the output like this. So what is this characteristic equation means? Let's try to plot the inputs. So how many inputs are there? Two inputs are there. Let us try to plot it and let's try to derive the expression of this one. So first input is D, and we are going to draw like this, and the another input is nothing but Q1. Okay, so here only one input is there. The possible is 0, 1, and here it is qn. Then you are going to have two outputs 0, 1. So this way of finding the characteristic equation is done with an k map, which is called kernel map. Okay, so we need to derive this expression. So first we will mark 0 as well as 1, and the next also will mark it as 0 and 1 on the x-axis as well as the y-axis. How to write down d means 1 we can write down it as d, and 0 we can write down it as d bar. So here q I can write down it as qn, and 0 I can write down it as qn bar. Okay, so this is how to write down. Now you see here, d is 0 and qn is also 0. What is qn plus 1? Qn plus 1, we are going to get it as 0. If d is 0 and qn is 1, then you are going to get the output as 0. And if d is 1 and you are going to have, so if d is 1 and qn value is 0, okay. So d is 1, qn value is 0, then you are going to get 1, and d is 0. Just we'll try to check out. So 0 0 means you're going to get 0. So 0 1 you're going to get 0, and for the combination of 1 0 you're going to get the output as 1, and for the combination of 1 1 you're going to get it as 1. So here you can see here you have been got the two values, and you are going to encircle it, and you are going to find out 0 0 1 1. These are nothing but called as the next state, which is qn plus 1 is equal to, so they are getting mapped. So you can see here these two are linked with the d value. Therefore, qn plus 1 is equal to d is the characteristic equation of next state using an k map. Okay, so now we can see here how the output is going to change. Okay, so if you draw the timing diagram, let us try to take here. So this is nothing but and let's try to change the color, then you can understand better. So this is nothing but our clock pulse. I'm drawing only for two cycles. And first this is called and positive and negative. Therefore this is called a clock period. So this is called clock period, and this is called the next clock period. So here in this clock period, when you're going to get the output. So here this is the input, and you're going to get the output as qn plus 1. So this will be delayed by 1 second. For example, so this is 1 and it will delayed by 1 second. Okay. So 1 cycle it is getting delayed, and here it is 1 and it is becoming 0, and it gets delayed by one clock period. So by one clock period it is getting delayed. Therefore, these kind of things are called as delay flip-flop or delay memory storage element. That's why this is called a delay flip-flop. Here you can, if you want to do, you can take the input as a D. Okay, if a D is 0, qn plus 1 is also 0. Okay, so like this, if you draw it, so if you want to draw it, you can draw it. So if D is positive and Q is also positive, so this is nothing but a D. So this is the value of D. So if D is 0 and Qn plus 1 is also 0. If D is 0 and 1, you are also going to get the same. Okay. So here when you draw the output, this will be similar to that of your Qn plus 1, which is nothing but Qn plus 1 is equal to D. So that's why it's called delay flip-flop. Hope you're able to understand. So like this, more videos will be available in our channel. If you are interested, you can go ahead and you can learn the things. So I repeat the question things again. So characteristic equation of a D flip-flop is Qn plus 1 is equal to D, and flip-flop is called as an 1-bit memory storage device. This will work only when if we give the clock pulse. And D is nothing but delay flip-flop. And from SR flip-flop, by giving the first input to S and the inverted output to R, you are going to get an SR flip-flop with NAND gate. And this is the truth table of our D flip-flop. And this is how we are going to construct the characteristic equation using K-map. And this is called the way we are indicating time t equal to 0, and this is called as the timing diagram. Hope the thing is clear. We'll meet in another video. Thank you for watching.